Hello and welcome to the second in a series of webinars that Enable Training and Consulting is proud to do in conjunction with National Instruments, specifically covering how to use LabVIEW within the FTC First Tech Challenge game competition. So thank you very much for coming back and watching the second in this series of videos. What we're going to talk about in this one, we're going to begin with just a quick review of what we covered in the first webinar. In particular, we're going to talk about how to deploy to the brick, the schematic editor, joystick driving. We're going to do a very quick summary of the code that we developed in the first webinar. And then we're going to move on to create some slightly more complicated code for a more sophisticated robot, where we've taken a simple bot that was used for behind the scenes for the first webinar, which has just got simple DC motors to left and right wheels to drive, and a light sensor and an ultrasonic sensor, to add to that servo motors and the ability to drive them and make autonomous decisions based on what you see there. So I'm here joined again with Greg Sullivan.
Hey.
My name is Ben Zimmer, and thank you very much for joining us.
Okay, so we'll talk a little bit about what we looked at last time, and the first thing that we did is deploying to the brick, connecting to the brick with that as well. We talked a little bit about the schematic editor and configuring motors and sensors and servos. We also talked a little bit about joystick driving and how you can test all of your motors and sensors without even writing any code. So we'll go ahead and we'll hop into LabVIEW. And here is the Robot Project Center. Again, if you watched last time, you'll be familiar with this. We had our Choose NXT section, which is where we connect to our bricks and we manage all our bricks. If we have multiple bricks or just one, this is where we do all of our managing of that. Here is where all our programs lie. Here are all our programs that are deployed on the brick and run remotely. And here we have remote control configuration files, which allow us to control it remotely. Over here we have our schematic editor. We can open that up and take a look. Again, we have our DC motor controllers, and we have sensors. And we talked about how you can configure a multitude of sensors, and also how if you have a brick hooked up, you can view live results coming from all of these sensors, and using that you can configure and diagnose problems and make sure that everything's working properly. We also talked about DC motors. We talked about the importance of labeling DC motors, sensors, and servos, and how that comes in handy when you're coding down the line. We also talked about how you can use a schematic editor to test all of your motors live, and also the importance of this reversal button here, which allows you to make a global edit that makes sure everything's headed in the right direction. We also talked about servo controllers and a little bit about daisy training and how that works. And we also talked about servos a little bit, and we're going to end up talking more in depth about these later in this webinar. We'll go ahead and exit out of that. We also talked about joystick and remote control configuration. We'll take a quick look at that again. We talked about the three different types of drive: our arcade left, our arcade right, and our tank. We also talked about configuring your motors here, and again, this is an example of why labeling your motors comes in handy down the line, because if I had to just name them motors 1 and motors 2, I have to all of a sudden remember which was which, but since I've named them conveniently, it's nice and easy. We can also tone down or up our motor power and invert directions. We can also define very specific actions for different buttons and axes. And the more complicated your robot gets, the more this allows you to do. And there's a multitude of buttons here on this controller that allows you to really take control of your robot however you want to. We also talked about how you can use a keyboard to run it, or your controller, and how to actually go ahead and run that, as well as view sensors live. Also, we may have mentioned the generate code button here, which actually allows you to take your whole remote control configuration and turn it into a VI, which can be deployed remotely as a teleop program for use for FTC later on.
And that's a topic that we'll be getting into much more detail in one of the later webinars.
Yeah. Another thing we talked about last time was the difference between the run, the deploy, and the debug buttons, and also the abort execution button. And as from before, the deploy button is just going to store your program in memory, and you're going to have to manually run that from your brick. Your run button is going to open your connection. It's going to store a program onto the brick, and then it's going to immediately run it. The difference between these and the debug button is that there's no live connection with those. When you hit the debug button, a connection remains with your brick, and this allows you to view live results on your front panel. And it's a good way to diagnose problems with your code, or also to just see what's happening with your sensors live. And it's an overall good way to make sure your program's running smoothly.
Great. Thank you, Greg.
No problem.
So what I wanted to do now is just a quick summary of the code that we created in the end of webinar number 1. Just as a quick reminder, this was a line follower code that really performed the line following action in 3 steps. The first step, the robot would drive forward until it saw a line. And remember that the way we determine whether a line has been seen or not is by the downward facing light sensor. So if the light sensor reads a value less than 50, that's an indication that it's on the line. So the first part of the code drove forward until it saw the line, then began turning right at a slow speed until it was off the line, and from that point onwards followed the algorithm that we see on the screen here, where depending on whether or not the light sensor is on the line, it will either turn left or right. And you can see here an explanation, visual explanation at least, of how that will allow the robot to continue turning in the right direction to make sure that it follows that line. So what I'd like to do really quickly, we saw this code, we saw it be created last time around. I'm not going to do that again. Let's just look at it very briefly, and then we can talk through it, make sure we revisit all the functions and all the important characteristics and pieces of the code that we developed. Just before I do that, though, I want to show you how to access this code so that you can pull it down and look at it yourself. We'll start off as a great landing page for all of this material that we're presenting is tetrixrobotics.com/FTC. And this landing page will be continuously updated as we continue through the weeks. We see that the webinar 1, which we did last week or 2 weeks ago, the videos are available to be pulled down off of YouTube, so it's a very convenient place to access those videos after the fact. We can see here that you can register for future webinars, so please go ahead and do that. As soon as this webinar is done, go ahead and click and register for webinar number 3. We look forward to having you back. And also on the left-hand side here, notice that there's 3 different pieces here. There's the Tetrix Getting Started Guide, which is the introductory material we're going through now. Then there's some FTC-specific extensions. So as Greg alluded to, the Generate Code button is a feature built into LabVIEW that's very specific to FTC behaviors. And that dealing with that and how to activate those features and use them properly within the FTC context is going to be things that we cover in webinars 3, 4, and ultimately in 8 when we get to advanced concepts. And then the third piece will be the Tetrix Mastery, which are some advanced programming concepts, which will be covered by webinars 5, 6, and 7. So to jump back into the Tetrix Getting Started Guide, and then click on Extensions, and then if we click on the first extension, which is the line follower, here is where we can access that same code that we created in the webinar last week. Go to the Programming section, select Sample Programs, and from here you can download a zip file that once you've extracted it, you'll see the same thing that you see on this screen in LabVIEW. You'll see Program 1, 2, and Program 3. So I'm going to open up Program 3, which is the collective program which does all 3 of the pieces of the line follower that we discussed. Let's just go through it together really quickly. I'm going to expand the window so we can look at a large chunk of the code at one time. There were only a couple things from the webinar last week that I asked you to make sure that you remembered, and one of them is Control-H, or accessing the context help. So when we press Control-H, the context help window appears, which allows us to hover over any object and get a bunch of information about that particular function, constant, or structure. So just to refresh, the goal was to drive forward until it saw the line. So the very first activity was to set the motor speed. In this case, we're going speed 15, and notice how both motor commands, both to the left wheel and the right wheel, were set to the same power. That's going to make sure the motor goes straight. From then we go into this next structure, which is a rounded edged rectangle called the while loop. The way the while loop works is it runs over and over again. The code inside it runs over until a condition has been met. In this case, the condition that we're reading is actually the light sensor value. So we're going to keep reading that light sensor until the value is less than 50. Then we're going to stop the loop. And then we move on to the next function, which is to actually stop the motors. So this chunk of code here achieves that first goal, which is to drive forward until we see a line. And the rest of the code, as you remember, was a lot of copying and pasting. The functionality is very, very similar, and that's why it's really important to understand the basics when programming with LabVIEW. Have a very clear algorithm. But once you get going and once you actually start programming your code, you're going to see there's a lot of repetition of code, which makes a visual programming language like LabVIEW really, really easy to learn, really, really effective to create really complicated code. So once we've gotten through that first stage, our next step is to have a short delay. So we put a delay function in here with a value of 0.5, which is half a second. And then we just change our behavior slightly. So instead of going straight, we give different power commands to the left and the right wheels, which is going to cause the robot to turn. And again, we have our while loop. In this case, we're checking until we get off the line. So again, we're reading the light sensor value over and over and over again. Whereas in the first place, we're checking to see the light sensor value is less than 50 before we stop. Now we're checking for the value greater than 50 before we stop. And as soon as we're off that line, that value will be greater than 50, and then we come out of the loop and we stop the motors again. So again, the first part of the code and the second part of the code are almost the same, just a slight replacement of the constant values for the speed and the comparison function. And then the third part, which you would think would be the most complicated, is really very similar. This is where we're actually following the line. So here we're making a decision. If we jump back into the PowerPoint for just a moment, we see the decision is to turn left or right depending on the light sensor reading. So turn left if the value is less than 50, turn right if the value is greater than or equal to 50. So back into our code, we see we've got the same, basically the same stuff, except now we've added an additional structure. This is called a case structure. And this was just like the if-else function from a traditional programming language. If our light sensor reading is less than 50, it comes into this case selector terminal here. We execute the true case, which is going to be to cause this term. If the value is not less than 50, then we go to the false case, which is going to cause this turn. And then the only piece of this code which is slightly different than what we demonstrated last week is the use of the NXT button function in order to actually stop the code. When we did it in the webinar, just to make things a little bit simpler, because we had a lot to cover, we just put a constant value of false here to make sure it ran forever. And just to point out where this function can be accessed, it's really treated just like a sensor. So if we bring up our functions palette, our NXT.io, and choose our sensor block, when we place that thing down, we've got this pull-down tool, the polymorphic VI selector, that chooses the behavior. And what we use this to read the light sensor values, but we could alternately use it to read the NXT buttons. So the same sensor function, just in a different mode, can be used to make your code run until you press a button on the actual front of the brick. So that's a quick summary of what we covered in the previous webinar, a little rehashing of the way that block diagrams work within LabVIEW, a reminder of the way that functions and constants are all connected together using wires. There's this analogy that the order of code within LabVIEW is determined on a data flow nature, which means that data must flow from one function to the next. And we talked about how we use the NXT terminal to make sure that there's at least one connection between all of our functions so that we can make sure things happen in a prescribed order.